The open loop transfer function of unity feedback system is given by g of s equal to k divided by s into s capital T plus 1. This is not discrete value, capital T plus 1, where k and t are positive constant. This is the data given. We do not know anything about what is the value of k and t, but both are positive. By what factor? By what factor should the amplifier gain k be reduced so that the peak overshoot of the unit step response of the system is reduced from 75% to 25%? Here we should know what is peak overshoot. So I hope you are all so familiar with undertimed response undertimed control system when the response when excitation is unit step signal. So the response will be something like that. So this is the final value 1, and the response will oscillate on this line, that is value 1. So now when you are exciting with the unit step signal to the control system, the response will go to the maximum value, and slowly the response will oscillate and it will reduce to 1 at t is equal to infinity. Now what they are asking is, you have to do some manipulation or do something on input signal or gain or something like that, some other parameters to reduce the peak overshoot, this value. So that the peak overshoot will reduce from 75% to 25%. Initially you can assume that this is around 75%. In which occasion, in which condition the response will become 75% to 25%, that is peak overshoot will reduce to 75% to 25%. So actually it should be is equal to 0, because if it is 0 then the response is 1, but because of the nature of the components in the control system, the response may oscillate in between some maximum peak to maximum value to minimum value, and it will reduce, and by the assumption that the value will become 0 at t tends to infinity. So if the value of t is infinity, the response value will become 1. This is the condition. So now we are going to determine the value of amplifier gain k, so that because of changing the value of k, we are going to reduce the peak overshoot from 75% to 25%. And hope you know this is the closed loop control system block diagram, and from the problem itself they have given like unity feedback and and open loop transfer function is k divided by s into s capital T plus 1. Now first step is we are going to find out closed loop transfer function. You know how to find out closed loop transfer function. So for all the problem, first step is to find out closed loop transfer function if they have given only open loop transfer function. If they have directly given closed loop transfer function, then we don't need to follow these steps to find out closed loop transfer function. Directly we can use that formula to find out the parameter value. Here the formula to find out closed loop transfer function is C of s by R of s is equal to G of s divided by 1 plus G of s into H of s, and here we know that the feedback is equal to 1, hence C of s by R of s is equal to G of s divided by 1 plus G of s. You have to substitute the value of G of s given k divided by s into st capital T plus 1. So when you are substituting the value of g of s in this equation, this is a simple mathematical calculation, and when you are doing these steps, you will get C of s by R of s is equal to this simple cross multiplication and simple multiplication and division only. So you will get k divided by, so here k divided by s square into capital T plus s in s plus k. Now we are going to divide the denominator by t and numerator by t. When you are doing, when you are dividing numerator and denominator by capital T, you will get k by t. This is k by t divided by s square plus 1 by t into s plus k by t. So this is the closed loop transfer function. This is the closed loop transfer function. Now we have again second step. We are going to equate the closed loop transfer function, the standard formula to find out zeta and omega n. So we have standard equation, the same step. There is no, I'm not doing any different way to solve the problem. I'm not proceeding with different way. The same steps we are going to follow to solve this problem. So we are going to compare closed loop transfer function with the standard format. So this equation, that is k by t divided by s square plus 1 by t is plus k by t is equal to omega n square. This is a standard equation. So omega n square divided by s square plus 2 zeta omega n is plus omega n square. When you are comparing these two things, we will get omega n square is equal to k by t. When you are removing this square, you will get omega n is equal to square root of k by t, square root of k by t. Now we are going to compare 2 zeta omega n with the coefficient of s. So 2 zeta omega n is equal to 1 by t. From this we are going to determine the value of zeta. Zeta is equal to 1 by 2 omega capital T. See, we already determined the value of omega n is equal, you have to substitute the value of omega in this equation. You will get 1 divided by 2 capital T square root of k by t. So you can cancel this t. You will get zeta is equal to 1 divided by 2 into square root of kt. So by comparing the second order equation, that is second order standard equation and the closed loop transfer function, we got the value of omega n and zeta. Omega n is equal to square root of k by t and zeta is equal to 1 by 2 into square root of kt. Now the peak in the problem, they said we have to adjust the parameters to reduce the peak overshoot from 75% to 25%. This is the problem they have asked. Okay. Now the peak overshoot MP is reduced. Generally, this is a very important statement. All of you must very key, must give importance to these two statements. The peak overshoot MP is reduced by increasing the damping ratio zeta. We have a formula to find out peak overshoot, that is MP here lost. MP is equal to minus zeta pi divided by square root of 1 minus zeta square. If you really want to decrease the value of peak overshoot MP, then it is required to increase the value of zeta. If you are increasing the value of zeta, automatically the value of peak overshoot will reduce. At the same time, the damping ratio is increased by reducing the gain, because we have a relationship between damping ratio and gain k in the previous slide. So here zeta is inversely proportional to gain. So zeta is equal to 1 by 2 into square root of k into t. Hence Both are inversely proportional. So if you really want to increase the zeta value, then you have to decrease the value of k, or vice versa. Here we need to uh, increase the value of damping ratio. It can be done only by reducing the value of gain k. Now, in the problem they said the peak overshoot m suffix p is equal to 0.7. They have given the value of initial value of peak overshoot, that is 0.75, that is 75 percentage. For this particular condition, we are going to consider zeta is equal to zeta 1 and the gain value k is equal to k1. Then it should be reduced. 0.75 percentage of peak overshoot should be reduced to 0.25 percentage. So for this particular condition, zeta value, we are going to assume that zeta value is equal to zeta 2 and k value is equal to k2. So these are the two important conditions given the problem. So our main task is to reduce the peak overshoot, percentage of peak overshoot from 75 percentage to 25 percentage. For example, if the peak overshoot is 75, then the zeta value and k value may be different. At the same time, if mp is equal to 0.25, the zeta value and k value may be different. For that particular purpose, we have considered when peak overshoot is 0.75, we assume that zeta is equal to zeta 1 and k is equal to k1. MP is equal to 0.25, and when MP is equal to 0.25, zeta is equal to zeta 2 and k is equal to k2. Now, this is the formula to find out peak overshoot. Now, from this peak overshoot, we are going to find out zeta value, because in this particular formula, we have MP value, two different MP value, that is peak overshoot value, that is 0.75 and 0.25. And from this particular equation, we need to find out zeta value, damping ratio. அதாவது எப்படின்னா, given ப்ராப்ளத்தை என்ன கொடுத்துருக்கு அப்படின்னா, பீக் ஓவர்ஷூட் வந்து 0.75ன்னு கொடுத்துருக்கு. அவ்வளோதான் நமக்கு தெரியும். அந்த 0.75ல இருந்துட்டு இந்த ஈக்குவேஷனில் சப்ஸ்டியூட் பண்ணி we need to find out the value of damping ratio. எப்படி அப்படின்னு பார்க்க போகிறோம். Now, first we have to take natural log on both sides of this equation. When you are taking natural logarithm, so log of e, when you are taking logarithm of e power something, then e and log will go. So because of that, log m suffix p is equal to e and log will cancel. So minus zeta pi divided by square root of 1 minus zeta square. First step is we have to find out a natural log on this to remove the exponential. Next step is we have to square both sides. When you are taking square on both sides, you will get log mv square is equal to zeta square pi square divided by 1 minus zeta square. So this square, we have taken square to remove square root in this equation. So if you want to remove square root, we have to take square. So when you are squaring on both sides, you will get this equation. Now we are going to cross multiply this equation, that is, we are going to multiply these two things. When you are doing this, we will get zeta square pi square is equal to 1 minus zeta square natural logarithm of m suffix p the whole square. So you can multiply log mp inside this bracket, you will get log m suffix p this square minus zeta square log m suffix b the whole square. So now we are going to separate this equation. We are going to separate zeta variable one side and mp other side. So zeta pi square plus zeta square log mp square is equal to log mv square. Now you are going to take zeta square outside. When you are taking zeta square outside, pi square plus natural logarithm of mp the whole square is equal to natural logarithm of mp the whole square. So now we have to divide it. So zeta square is equal to, natural logarithm of m suffix p the whole square divided by pi square plus natural logarithm of mp square, which is equal to 1 divided by kt. What is this? We have already determined. We have already determined zeta value by equating. So zeta we have determined 1 divided by 2 into square root of kt. When you are substituting that in this equation, zeta, when you are squaring 1 divided by 2 into square root of kt, you will get zeta square, that is equal to 1 divided by 4 into kt. This we have already determined in the previous slide. Now we are going to equate these two things to find out mp. Now zeta square is equal to 1 by 4 kt. Now I am going to rearrange this equation like I am going to multiply 4t with the numerator of this equation. I will get 1 by k is equal to 4t into natural logarithm of mp square divided by pi square plus natural logarithm of mp the whole square. Now we need only k, not 1 by k. So we are changing numerator into denominator to find out the value of k. So k is equal to pi square plus natural logarithm of mp the whole square divided by 4t into natural logarithm of mp the whole square. So we have got a formula to find out the value of k by substituting peak overshoot value. So we have peak overshoot value 0.75 as well as mp is equal to 0.25. We are going to substitute these two values in this equation to find out the value of gain k. We have assumed that gain k is equal to k1 when peak overshoot is 0.75 and k is equal to k2 when peak overshoot is 0.25. So simply you are going to substitute the value of 0.75 and 0.25 in this equation to find out k1 and k2. First we are going to substitute k is equal to k1 when peak overshoot is 0.75. When you are substituting 0.75 in this equation, you will get k1 is equal to pi square plus natural logarithm of 0.75 the whole square divided by 4t into log to the natural logarithm of 0.75 the whole square. So you have to use calculator to find out the value of all these things and you have to solve this equation. You will get 30.06 divided by t when the peak overshoot is 0.75. This is the value of k1. Similarly, you have to find out the value of k2 when peak overshoot is 0.25. So the same procedure, you have to substitute peak overshoot is equal to 0.25. You will get 1.53 divided by t. So we have two gain value, that is k1 and k2. k1 related to 0.75 peak overshoot and k2 0.25 peak overshoot. Now we are going to take ratio of these two things, that is k1 by k2. So we are going to find the ratio of these two things. k1 by k2 is equal to 1 by t into 30.06 divided by 1 by t into 1.53. So this two are the 1 by t and 1 by t is cancel. We can cancel these two things, and when you are dividing 30.06 by 1.53, you will get 19.6. Now we can say that k1 should be we can say that k1 is equal to 19.6 into k2, or we can write k2 is equal to 1 by 19.6 into k. So we have determined the relationship between k1 and k2. k1 is related to peak overshoot is 0.75 and k2 is nothing but peak gain of the control system when the peak overshoot is 0.25. Now what they asked in the problem is, it is important to reduce the peak overshoot from 0.75 to 0.25. So k1 to k2. So If you really want to reduce the peak overshoot from 0.75 to 0.25, you have to reduce the value of k from k1 to k2, that is 19.6 times. You have to reduce the value of gain to reduce the value of peak overshoot from 0.75 to 0.25. This is the answer for this particular problem. So you can you will get a problem similar to this kind of problem, or previous two problems, two or three problems. These are the standard problems, and I think most of the problems in the book we followed the same procedure to find out all these parameters. Okay, so I'm stopping. I have discussed four problems related to time responses and these topics. So with this, I'm stopping the problem, and I kindly request you to follow any textbook or even some other book to get a lot of problems and solve it. And meantime, we are also have a plan to give a assignment in the sense combined assignment, the group assignment. We are actually finding a different set of problem from the textbook and also from the net, so that you will get a lot of ideas related to these topics. Now, actually, I want to start next topic. Before that, if you have any questions, you can ask me. I'll give you 1 or 2 minutes. If you're asking a lot of questions, then no problem. We will extend it. Otherwise, I'll switch over to next topic. Any questions? These two problems. I keep on talking, and I do not know whether you people are listening or not. I hope you are listening, because I have given the materials for all these slides. If you have materials in your hand, it's very easy to follow. Otherwise, it's very difficult. Any questions? Quickly. Any questions? Somebody can say no question, or I have questions. Some representative. Anybody? Because I need to switch over to next topic. I have to complete a lot of topics. Any questions? Quickly. At present, there are about 34 students attending my class. 34, 33, including myself. Any question? No question. Okay, I'm moving to next slide. Next, we are going to discuss about type number of control system. This is a very important topic related to time response. We should know what is type number and how we have to find out type number of a control system. So the number of poles, type number is nothing, number of poles of the loop transfer function lying at the origin decides the type number of the control system. So we can say about type number by seeing how many number of poles at the origin. Origin in the sense, when you are drawing x and y axis, the center point is origin. For example, you take this x and y axis. This is x and this is y axis, and the number of poles at the origin decides the type number. For example, if there is no pole at the origin, then we can say that type number is equal to 0. If you have one pole, type number is type 1. Two poles, type 2. Three poles, type 3. N poles, then the type number is n. So here n is the number of poles at the origin, okay, of the loop transfer function. Now we are going to discuss about what is loop transfer function and how the type number can be found. So just consider this is the loop transfer function. Loop transfer function, it's the ratio of two different polynomial, that is p of s and r of s. K is the gain. K is the gain. That is G of s into loop transfer function is nothing but G of s into H of s. This is multiplication of open loop transfer function and the feedback. So k into P of s by Q of s, P of s the numerator polynomial and Q of s the denominator polynomial. Just assume that this G of s into H of s is k into s plus z1, s plus z2 and it is go up to infinity and divided by s power n, s plus p1, s plus p2 and it's go up to infinity. For example, just take it here. Z1, Z2, Z3 and Zn, all these are called zeros of the transfer function. That is numerator, the factors of in the numerator, factors of the polynomials of the numerator is actually called zeros and the denominator, factors of denominator polynomial is called poles. Here Z1 is called 0, Z1, Z2 are called zeros and P1, P2, P3 and etc. are called poles. Here we have s power n. Here p value is equal to 0. Okay, p value s power n is here the p value is equal to 0. Here if you are taking this factor s plus p1, then p value s value p value the s is equal to p1 minus p1. Here s is equal to minus p2. Here s is equal to 0. The value of s is equal to 0. That is p is equal to 0. Here different values. Okay, if p is equal to 0, that is s is equal to 0, then the pole is lying on the origin. The pole is available at the origin. In this particular case, there are n number of poles available at the origin. We do not know the value of n, hence we can say that n number of poles are located at the origin of the loop transfer function. Now, n, I told you that n is nothing but number of poles at the origin. For example, if n is equal to 0, then the system is type 0. Okay. At the same time, if n is equal to 1, the system is type 1, n is equal to 2, type 2 and so on. If n is equal to n, then the type of the system is type n. This is what we can understand about type number of a control system.